demonstrate and talk about the NSP and its laminating properties. I'm going to do a simple lamination, a below-knee lamination with a 4-prong pyramid put inside to attach it to the socket or to the leg. So first thing I do, I've already got a PVA bag stretched over this model. I'm going to put on a very sheer nylon. This is an RX Textile Flex and Stretch nylon, and I put this on more than anything else to allow the ease of putting a good edge on the fiber. So on the finishing, this helps me get a better edge. So this sheer nylon doesn't add any integrity, any strength. It just purely makes finishing an edge better. So I've got that applied. The next is we're going to put on a layer of the NSP. I'm going to put on 2 layers. Now you'll find with this fiber, it's reasonably tough. It's a natural fiber. It was designed and built for the ballistics industry. It requires a sharper pair of scissors. Dull scissors are not going to work. But it doesn't, and also, unlike Arlon, it doesn't dull the scissors. So it doesn't require any kind of a ceramic scissor or anything like that. A regular scissor works fine, just have a sharp one. So if I want, I'm going to end up doing a 4-layer NSP lamination. Okay, so we're doing the NSP, the first layup. This is just going to be 2 layers. The number one cause for a 4-ear pyramid to fail in a socket is the material underneath the pyramid. If you put nylon underneath, these ears will push through the inside. Nylon's not adequate. Fiberglass braid is adequate. Fiberglass mat is not as adequate because it fractures easy. NSP is a very tough, durable material. It works very well as a surface underneath the pyramid so it doesn't fail. It's not the material on the outside that fails, it's usually what's underneath. So I'm going to do 2 layers underneath. I'm going to do 2 layers on the outside. Now try to get the wrinkles out before you fold this over. If I want to have this as a smooth finish on the outside and I don't want to show any braid, I can use a standard nylon. If I wanted to add a little more stiffness to this, between the layers of NSP, I could have done 2 layers of Niglass or any kind of filler material to separate the NSP, which will add a lot of strength to the actual lamination. We could also, if there's a severe issue with an ear bending or something like that, you could also add carbon fiber. But we're trying to avoid carbon fiber to avoid the itch. Back up. I'm just going to put 1 more layer of this thin nylon. So at this point, we just have 4 layers of NSP. And in essence, 4 layers of the sheer nylon. Now the one other thing that the sheer nylon gives us is it makes it, so when I take my PVA bag, and if I flip it inside out because I want a glossy finish on the outside, NSP has a tendency to really stick to that PVA bag. So by having this nylon, it slides over really easy. So I like to stretch this flex and stretch up quite a bit so that when I'm stringing out the resin, it doesn't put any wrinkles in it. So before I go from here, I like to make sure that I got my flexion angle about where I want it. I got my adduction angle about where I want it. I got my line of progression about where I want it. Now, in laminations, it's near impossible to make it perfect unless you do a 2-part lamination and you're using a Milmo to set that up. But this will get us right in the ballpark. We have plenty of adjustments afterwards with the pyramid. Okay, so my next step is I'm just going to pull a PVA bag on it and apply resin. Add a little bit of resin. I just put a string around here because I want the resin to go underneath the pyramid first. And wait till you start seeing resin come out underneath it by the vacuum, sucking it down and getting it under the side first. You see it start working its way out because I don't want any air trapped underneath the pyramid. So I just get the vacuum to do its job for a little while. Now, it's important because I'm running a really high vacuum that I do not force the material through. I'm letting the vacuum do the work. So I just kind of bring it down to the edge and let the vacuum suck it through the fibers. Now this fiber is such that it really likes to wet it out. It does not have a property where it likes to trap air. It wets out very fast, and it does not keep air trapped inside of it. But if you're mixing it with other fibers, particularly if you're mixing it with carbon fiber has a tendency to trap air. And all of you that have done laminations in the past, they know what I'm talking about. It takes extra care to make sure you do not get air trapped in a carbon. This is not as technical to get a nice, clean lamination. The other thing this fiber does, because it wets out so well, I don't need a lot of resin. Technically speaking, we need 35 to 50% resin to fiber content. Right now you can see where it's a little darker color, you can see where I got a pool. Well, pooling of resin doesn't help anything. It doesn't make it stronger, it actually makes it weaker because the resin has no strength, the fiber has the strength. The resin is the bonding property for the fiber. So I'm just going to work this down. If you could see real close, you'd see when I'm working it down, there isn't any air to be seen drawing this down. There's no air in that fiber because I just let the vacuum do the job. I'm just going to put a little tape and draw that resin up. Now as long as there's a pyramid with a hole in it, it'll suck all that resin into our lamination. So if we care, pinch it off, send it up to the top so we're not pulling more resin in. We don't need any more resin. We got plenty. Now this fiber also, because of its wetting properties, it doesn't require a lot of massaging. It doesn't require a lot of stringing. What you're looking for is a nice, clean pigment color. If you can see where it's darker, you know you got a pool, you need to work out the pool. You just want to look for uniform. You got uniform, you have what you want. That's it. Time to just walk away, let it go off, and then we'll trim it out. All right. So we've done the lamination. We've cut it out with a cast saw, just a regular cast saw. It's nice and stiff. It's 4 layers again. Remember, it's 4 layers of NSP, and it's 4 layers of that really sheer nylon, which really doesn't have any effect on the strength of the socket. So what we're going to do now is I'm going to cut it out. I'm going to show you how not to do it and how to do it. Okay? Because there are problems with using dull sandpaper. Okay? And the reason why dull sandpaper, paper is used with carbon, carbon's an abrasive, carbon will dull out a sandpaper. I'll show you what I'll do to the socket. I'm going to make some noise, so I'm sorry about that. So what it does is you can see it's pulling fibers out of the lamination. Now if I was to push really hard on this dull paper, what it'll do is NSP is a real good thermal reacting fiber, and it'll take the heat, suck it into the lamination, and literally make it delaminate. It'll ruin the resin. So what we want to do is not force it, not push it, use something sharp so the heat is down. So we're not applying heat, we're not wearing it out, we're cutting it away. Okay? So let me get rid of the dull stuff. Now I'm going to use a cone. This is also a cone that's not brand new, which would be best, but it is a cone that's still sharp. So this is a coarse cone. When I'm grinding, rather than going along the edge, I'm going along the side, so I'm breaking it towards the center, breaking it towards the center. So you can see with a simple light, I didn't push, I gave a light force, I took all the fuzz away, I cleaned up that edge pretty easily. Now we've done all the edges. Now a little note, if you cut with a sharp cast saw closer to your trim lines, just use a fine sandpaper. The fine sandpaper does a better job of cutting and not shredding and pulling this fiber. This fiber is really tough and it wants to be pulled. It doesn't cut as easily. So anyway, all we have to do right now is do a little hand sanding and we'd have our edges finished. It is plenty strong and stiff. This is just 4 layers of only this material, and then the 4 layers that really thin nylon. You can see the braid of this material. You can see inside the same thing. You got the braid. This is plenty strong as it stands. Does not mean you have to use only this material. If you had a desire to make the ears stiffer, you could put more of this material. You could put carbon fiber in order to stiffen it up. But the issue with carbon fiber, and the reason why this product was developed, is to compete with it in cost, number one, and secondly, the byproduct that I appreciate is that it has no itch factor. I didn't wear long sleeves because I'm working with this. I could go no sleeves, whatever, and I don't itch. So that's a really big thing for me. The other thing that I really like is that everything in my office is not covered with that fine black dust. It's a heavier dust. This is a heavier dust. And it just drops down and goes into the vacuum system easier. So anyway, that's it. NSP, CSP, and you can have a lot of fun with it, and you can go with all kinds of colors, takes any pigment beautifully. Laminates easy, and it's very affordable and really, really, really tough, strong socket. Thank you.